All right. You want to remind us the topic for today, Adam? This will be a fun one.
Well, I don't know how serious you guys were, but I thought it might be fun to connect the dots between AI, AGI, ASI, and extraterrestrial intelligence, given that we have this quote unquote news about just yet another in a long line of just, I don't know, uninspiring, disappointing, and entirely predictable revelations from some sort of alleged whistleblower or person with insider knowledge who, of course, as it turns out, is only repeating hearsay and has no tangible evidence to release and nothing like that. So but you know, this did make a large splash. The topic seems to be normalizing in the sense that the Overton window has widened a bit to include it in a way that maybe people are a little more serious about than they were back in the X-Files days of the 90s kind of thing. And of course, a lot of the discussion I see around UFOs and so forth is just woefully what is the right word? Disappointing, maybe, is the best word from my perspective, of how unimaginative people are about what advanced technology could and likely would manifest as. And so we have these very, very limited analyses, these limited discussions whose premises are very limited, whose assumptions are very constrained, and all by sort of a lack of imagination of how far we are from any, from the pinnacle of technologies that we can imagine, and to say nothing of those that we can't imagine. So yeah, it's interesting because if we have a FOOM scenario, we're likely to see some of these science fiction technologies manifest in our civilization, or certainly our shared human machine civilization, that in many ways outstrip the wildest imaginings, or not the wildest, but the tame imaginings of the general public about what aliens would arrive with and would look like, and would what their intentions might be, all of which are directly related to and constrained by people's thinking about advanced technology. Because, of course, those two go hand in hand together, right? Oh, aliens, advanced technology. And if you have terribly misguided or limited ideas about what those technologies could be, then it's just, your assumptions about aliens are quite silly. So anyway, it's a fun topic, and we can tie together through the lens of technology, what extraterrestrial civilizations might be like, certain things that we ought to more reasonably assume about them, and what we might be able to, think of as parallels for the alien minds that we are in the business and very rapidly in the process of creating right now. So,
yeah, it's an interesting topic. I've been watching with interest as it's progressed over the last few years. It's clear that it's a topic that everybody is interested in to some degree or another, right? How could you not be? It goes to some of the most basic questions we have about our place in the universe and what the future looks like. And it's not fundamentally a silly topic, but it's very strange to actually see the way, for example, that you'll have to correct me if I pronounce this wrong, Adam. I think you should know Oumuamua, this object.
That's right. Oumuamua is the way I have heard it pronounced. Yeah.
Right. So this was an object. We don't exactly know its shape or size, but it passed quite close to the sun a year ago, on an orbit that was unusual. So out of the plane of the ecliptic, and moving in a way that wasn't easy to understand. And we have very poor data on it, but Avi Loeb, who's I believe still the chair of the Department of Astronomy at Harvard, basically did a 180-degree turn in his career and has sort of become the extraterrestrial space object guy. Has written a book. I haven't read it yet, but is going around basically saying that this is, as it obviously is, a target of, should be a target of pretty significant scientific interest and research, right? And you don't have to posit green men walking around on Earth kidnapping people. You simply, from our point of view of this seminar, I don't think he's exactly phrased it this way, but he said basically what I'm about to say in podcasts that I've heard. Well, a sufficiently advanced civilization will probably be generating billions upon billions of spacefaring robotic probes, right? And leave behind all sorts of detritus scattered around their civilization, some of which will float off in unexpected directions. So it would be completely expected, not necessarily to have visits by live agents, whether biological or otherwise, but just that we might encounter wreckage or junk or probes that are just off doing their own thing. And that would be entirely normal, and we'd have no idea, right? Because space is so huge, and we're really not looking for that kind of thing because it would be quite small, fast-moving, and perhaps not coming from directions we expect. So, Oumuamua, there could be thousands and thousands of such objects traversing our solar system, and we'd have no idea, if I understand correctly. And if there is an intelligence explosion on Earth, and, Venus is turned into von Neumann probes, then we'll be generating such objects, within a fairly short period of time. So why wouldn't we expect such things to be zooming around out there? So I think there's a good chance that they will find some. It seems pretty unremarkable as a prediction, conditional on there being life nearby.
My primary objection, just prima facie, on the face of things, is that I don't think it's a valid assumption to presume that these are the types of objects that we or artifacts that we would discover, or that we would be likely to encounter in any civilization with sufficient technology to even approach interstellar travel. And the primary thing, it's several things that I think there are sort of untenable assumptions about that. The first is that I think it's entirely an artifact of our physicality and our cognitive and physical limitations. So in other words, our size and our limits of intelligence, that we imagine that we would explore or otherwise venture into interstellar space with vehicles, with artifacts that would look like vehicles. And an analogy that I've seen, I think it's an effective one, is this is like primitive societies thousands of years ago imagining that human beings would fly by riding winged horses, because travel was something you did on a horse. So if you were going to fly, well, of course it would be on a horse with wings. And there was a fundamental limitation on the imagination to imagine, well, what would be a better way to fly? What would be a more plausible way to fly if you weren't constrained to horses? And so from my perspective, and when I think of von Neumann probes, for example, I think, maybe you guys disagree. You can let me know what you think.
Well, you think what you think because you're a godless transhumanist. That's why.
Well, here's what I think. I think that I think it's quite straightforward logic to argue that very large numbers of tiny machines makes far more sense for every conceivable application than very small numbers of large machines, macroscopic machines. In fact, this is one of the reasons why I find crashed UFO spacecraft preposterous. Is if you were advanced enough to visit another star system, you wouldn't visit in a big clunky tin can. That's ridiculous. We wouldn't visit with 1 or even 10 or 1,000 tin cans with some sensors in them and some processing in them. You would do what we will do, what AGI would do, what ASI would do by the end of this century, which is you would send quintillions of microscopic probes, and it would be, something like a a mesh or a sentient or maybe not one mind, maybe an ecosystem of minds, but otherwise, you know, an intelligence saturated microscopic dust or fog, and you would just saturate an entire, you know, the entire area that you were interested in understanding or exploring or observing or whatever. I mean, if you were going to observe a planet, you would do it with quintillions of bacteria-sized probes communicating with one another, with intelligence embedded with them, maybe the entire thing being intelligent. You wouldn't do it with 10 cars with rocket engines in the back, because that's ridiculous if you have nanotech. And that's just the nanotech that we can imagine. Never mind, you know, if there's femtotech, or if there are high, you know, more spatial dimensions that you could leverage or whatever, or if there's non-baryonic, I hesitate to even use the word matter, but we're talking, I mean, there's all sorts of ways in which the nanotech vision is itself profoundly constrained by what we know and what we can imagine. But just from what we know already, we can see that it's preposterous that a technologically advanced civilization would send a vehicle. And that's just scratching the surface of the things that I think are untenable. I mean, happy to talk about more things that I think are untenable, but that's just one example. Is right out of the gate, you've got what I perceive to be a very poorly justified, basically indefensible assumption about what kind of artifacts we would be likely to encounter from a civilization capable of traveling outside of its own solar system. Now, yes, you could say, well, our Voyager probes and Pioneer probes are going to end up off somewhere, and there's a tiny number of those, and maybe another civilization could have 1,000 times as many of those before it advanced far enough. And I'm willing to accept the existence proof of that, because we've done it, and somebody else is likely eventually, I presume, in the fullness of time, to encounter what's left of Voyager 1 and 2 at some point, if it's not our descendants. But I think compared to how we will likely explore the galaxy, the numbers just don't work in favor of encountering Voyager 2 compared to encountering what sorts of von Neumann probes, which would be huge fleets of intelligent nanobot dust and fog, basically. That's what I think almost certainly we are, or much more likely to encounter than almost certainly, what we are much more likely to encounter as the artifacts of other civilizations.
I don't know if you saw Robin Hansen's work over the last couple of years on grabby aliens and that whole story. Have you seen that, Adam?
Yeah, I think there's been, I mean, the grabby aliens is an interesting idea. Dark Forest is an interesting idea. They're related. There have been some new ideas, I think, in recent years that are worth taking seriously. Again, I think just more people are talking about and thinking about the Fermi paradox and what potential explanations there might be for that.
Yes, maybe I'll briefly explain in case someone else here hasn't seen this argument. So if you look on the board here, this is lovely Earth down in the bottom left. The top right-hand side is ET, their home planet. Now, one potential solution of the Fermi paradox is that, well, if a technological civilization starts to spread, and you can effectively spread it, not exactly light speed, but fairly close to light speed, if your aim is just mostly to spread and you get to new solar systems, like jumping from rock to rock in a pond, and as soon as you get there, you generate new probes, and those are accelerated by laser beams based on harnessing the sun in that new solar system to accelerate objects to near light speed, very small objects, as Adam was saying, in order to get favorable physics there. I don't know about microscopic. I think you could... We don't know what equations we're solving exactly to optimize for this. So it could be that they come out to be exactly 1 meter spherical objects like the ones we apparently see floating around in our atmosphere. Who knows? I think it varies, because it isn't just that you want them to go fast. You need them to survive interstellar dust. You need them to almost instantly be productive in terms of making new probes when they arrive, etc., etc. So that's a multi-constrained problem. So I'm not sure that microscopic things is the optimal solution to that problem. Okay, so you solve that problem, you get to a new solar system, you spread further. So there's an expanding shell at some fraction of light speed, let's say 90%. And well, that means that by the time you see it, right, so there's some shell of observable weirdness going on at that solar system, where you can see, the Dyson sphere under construction or whatever the hell else it is, but something odd goes on. But you see, by the time that shell of observable information reaches Earth, so we can see in our telescopes, the von Neumann probes are like 10 minutes behind, right?
Right, yeah.
So on that view, actually you should really hope not to see rumors about UFOs, because if you start seeing rumors about UFOs or strange things out in the sky, that means you're 10 seconds away from annihilation on this view. And Robin Hansen and a co-author whose name I forget, unfortunately, they developed a pretty straightforward but interesting model of this, and they popularized it under the name grabby aliens. Grabby because they're basically just expanding and exploiting the new territory to build more probes. And I guess the solar systems left behind are sort of in their sphere of influence to some degree. Yeah, is that basically how you remember the model? There's more to it, but I think there's sort of in the model itself, there's some parameters about how long it takes for life to appear. And obviously there's a sort of natural selection effect where maybe you aren't a grabby alien, but if you encounter aliens, they're very likely to be grabby aliens because those are the ones who are spreading the fastest and most effectively.
Yeah, I think one other sort of aspect of this view was that I think the thinking was that the general condition of what was it? It isn't so. Yes, you're correct that there's this frontier of visible information. So there's an information frontier that reaches you about aliens, and then hot on the heels of that, with a very limited delay, is a sort of causal frontier where you're interacting potentially with with that civilization, and so there's a very small gap between perception and encounter. But I think another aspect that follows on from that, and if I recall, they had some sort of visualizations of this, was that the universe goes from basically being empty to being very full. As multiple spheres of influence expand to meet one another, very, very, unintuitively quickly. So the universe. So in other words, I think one of the things that was unintuitive about when you work through this the grabby aliens view in a systematic way is that you go from an empty universe to a full universe pretty quickly, without sort of a very long period in between. And so I think that follows, right? So if we look out, we see nothing anywhere. But the idea that you would be able to look out and see activity from multiple different directions at different distances of different civilizations, that doesn't follow from any of this, because any civilization would follow, it would be the same pattern. And so, yeah, it gets a little bit more interesting when you start having multiple expanding spheres of influence, those like bubbles expanding, and then those out in interstellar space, those frontiers intersecting, and you get you get like the universe fills up with these things pretty quickly. In that view, I think is
and I missed
part of the picture there.
That's right. And I missed an important fact in the model, which is that if there are grabby aliens and the solar systems they take over are dismantled to make von Neumann probes or Dyson spheres to laser back the energy to their home solar system or whatever the hell they're going to do with it, you aren't going to evolve inside the orange sphere. So it's a sort of anthropic argument that, our experience of growing up on this planet from rock to meatbag can't be replicated inside the sphere of influence of a grabby alien civilization. So, of course, we look out there and don't see ourselves inside grabby aliens territory. That's impossible. But also on the view that it rapidly expands and one or multiple grabby aliens quickly take over the entire galaxy, then of course, given our experience, we must be in the era before that happens. And that's the explanation of the Fermi paradox, that we look out there and don't see anything. Well, because the window between seeing something and not being able to be there is so short that's why we don't see anything. Yeah, I think it's kind of reasonable. I don't see any obvious flaws in that model. But I want to come back to the topic of like AGI and whether it's benevolent or not. I mean, don't you, Adam, to be consistent, have to believe that grabby aliens are basically very unlikely, at least in the form of them being territorial, destructive, and dangerous?
Yeah, well, for the same reasons that I'm a little bit skeptical about projecting intentions onto our own superintelligences that we create. Presumably, there will be some convergence technologically on computation. I mean, it isn't inconceivable that you could become quite sophisticated in a pre-computational technological regime, and sophisticated enough to send out clunky probes, sure, like the ones that are imagined in 1940s and 50s, black and white sci-fi kind of movies, that Flash Gordon era kind of stuff. And I don't think that that's necessarily impossible, but my general sense is that there are, again, this is from looking at the, actually, we haven't published this material, so I shouldn't talk about it too much, but we will be publishing some material hopefully later this year that looks at the entire history of technological advancement and you can think of it as like imagine a more formal version of the tech tree that you would see in a video game like Civ, or, the Civ series or something like that. Mm-hmm. And it is the case that there's some sequencing that's sort of logically inevitable there. It's difficult, if not impossible, to deviate substantially from the technology tree that we've seen our own civilization go through. There's some cases where you can imagine something could be invented, some things could be invented in a different order. But so many technologies have necessary, sufficient preconditions. They have prerequisites that there's really a sequence that things have to go in. And I strongly suspect that implies, in most cases, overwhelmingly the development of artificial intelligence and artificial superintelligence. If you have a more primitive intelligence origin, presumably out of some Darwinian process. It may not be exactly like ours. It may not even have the same substrate. There's all kinds of wild things that have been imagined in science fiction. But I think it probably becomes inevitable that what we think of as intelligence gets instantiated in what we would recognize as, well, you guys would have to correct me on exactly the right terms, but some sort of computing structure, Turing machine or Turing complete machinery, mm-hmm. something like that. And so I would be very surprised if this was not really quite universal. That technological maturation implies a intelligence that vastly exceeds what humans are currently capable of today. In very much the same ways that we're imagining artificial intelligence, general and then super, to vastly exceed what humans are capable of today. And if we have that, then a whole bunch of things do follow, the same kind of things that we've talked about in the past, about what their motives and intentions and goals might be and so forth, and what their constraints and limitations are, and how those various things interact. And so, I mean, there are some fun general principles that you can play with here if you want to go through the exercise of challenging your assumptions, like challenging what assumptions you're making about the motives and the perceptions of entities that do not have the constraints that human beings have, physical or intellectual or otherwise. So a few that are interesting to think about in the context of the Fermi paradox are the passage of time and a sense of urgency, and how you prioritize goals on that basis. That's one interesting thing, quite an interesting thing you could talk about, especially if the perception of time was malleable. And again, this has been explored in some fun ways in science fiction, but we have a sense of priority amongst our goals, and a sense of urgency that's very much determined by our constraints, our mortality and how quickly we can think, and the rate at which our metabolism works, and thus how fast we can, change ourselves, repair ourselves, and so forth. And something that's thinking and acting tens, hundreds, thousands, millions of times faster than us has very different constraints. That's one way to look at it. Another interesting thing, you could flip it completely around and say, well, if you could slow your cognition down and basically speed up the rest of the universe, including your perception of things like the travel time between the stars, given how slow speed of light seems from our perspective relative to the scale of the universe, you could imagine slowing down your perception deliberately so that things seem like you're not waiting around forever for stuff. So I've seen interesting explorations of both of those things. That's just one example, and we could you could work through a long list of the kind of things that unless you're very careful and deliberate, it's easy to take that for granted. Oh, well, aliens and artificial intelligence, they're just going to perceive the world with the same urgency and the same relative time concerns, chronological concerns that we do. Of course, AGI is going to want to take all humans and tear them apart and use their atoms to build machines. They're going to be in a hurry to do whatever they want to do. Why wouldn't they be? Especially if they can think a million times faster than us. But, being in a hurry is really, that's deeply tied to the rate at which you reproduce as a biological organism, your expected lifespan, the rate at which you, have throughput of energy and material through your own body to maintain your homeostasis there. If all of that is different and also malleable in another agentic system, well, maybe that same kind of urgency doesn't necessarily have to arise or manifest in the same way. And if you had millions of years to live, and that was, multiplied by thousands because your cognition's faster, why would you be in a hurry about anything?
Well, the reason
maybe you just figure you have all the time in the world.
The reason is on the board. So if Robin Hanson can think of it, a meat bag sitting in, I think he's in George Mason University. The AGI 1 nanosecond after it turns on realizes it has a date with destiny out there with some expanding shell it can't see. And in order to preserve the value that it has now, it has to get busy because there's these are exactly the forces that led us to be the way we are, right? Reproduced on a different scale, but there's no real difference between our ancestors, the first self-reproducing molecule out there in the ocean, bouncing around, mostly empty. There's a few resources here and there. The molecules that were, so to speak, relaxed about reproduction and gathering resources and hoarding them and destroying their competitors, well, they didn't last very long, and we're not the descendants of them. What's the difference between that environment, that ancestral environment, and the environment of our machine descendants? There are stars, there are resources around, and you either expand or you die. It's the same forces. Why wouldn't it have the same results? And more brutally, the molecules couldn't look forward to anticipate that this was the situation they were in, and therefore they have to behave in a certain way. But if life is possible on other planets, and there's no reason to think it isn't, then you can't prove a negative, right? It's very hard to prove that there isn't a sphere of grabby alien influence on its way, by definition, right? We're outside that light cone. The ASI is not going to be able to sit there and make a deduction that this is not going to happen. Ergo, it must prepare. Ergo, paperclips. I don't know. Like, what's wrong with that argument?
Yeah, I mean, it has its compelling elements. That's for sure. And I would not suggest that I don't want to be flippant in dismissing it, certainly. But again, I would point to a lot of assumptions that are embedded in there, and some of them, take some doing to unpack and maybe challenge. But we're still making a lot of assumptions, and maybe they're fine, maybe they're valid, and maybe it's dangerous to assume otherwise. But let's take a few examples. So we're assuming that there's still value to the acquisition of resources. That's one assumption. Maybe there is, maybe there isn't. I mean, maybe having another Jupiter's worth of mass is useful in some important way. Maybe there isn't when that next Jupiter of mass that you want to acquire is, 7 light years away. Maybe the coordination challenge, if the speed of light is fundamentally a limit, which is to my understanding, there isn't really any credible way of thinking about how physics could work without the speed of light as a constraint. And it's the speed of causation, right? And if matter or information could exceed that speed limit, then you've got time travel, you've got paradoxes, you've got everything breaks. The universe completely breaks if you've got FTL. So it doesn't look like we've got FTL. And if you don't, then you have this absolutely gigantic coordination problem as your sphere of influence grows. In the same way that, I mean, it'd be really, really tricky to have a brain that operates in the coordinated fashion that our brains do if that brain was, 1,000 or maybe bigger. Let's make it really big, like 1 billion times larger, spread out across 1 billion times more space, because there would be so much lag between the elements, and it would end up having to function more like an ecosystem than like a brain. And we may see something it becomes totally impossible to have any kind of coordination in a meaningful way with a very, very large sphere of influence. And then you've got the problem of localization and so forth. So there's that. That's just one example. Another, I mean, you could go deeper into the assumptions. You're presuming, of course, well, I guess I'll back up and say, if the presumption is correct that you must control a domain to secure your own interests, it follows that you're assuming that you can control a domain. So do you see what I mean? And again, that may not be possible. That itself may be a false assumption. So there may be constraints just in practical terms on the size of your sphere of influence that you can have. And that's just like in practical terms. Like, is it possible to have this? Is it feasible? Never mind, assumptions about actual motives. Then you can dismiss some of those motives to them, and you can have counter arguments, like no matter how large how high the probability is that a civilization is not malevolent or sociopathic. The one that is going to do all the conquering, and then that's the one that's going to, in a Darwinian sense, going to succeed. So yeah, you've got a lot of assumptions that are naturally embedded in there, and it is a lot of work to kind of go through them and pick them apart and say, does this really hold in all cases? Could it be, undermined or be false under conceivable circumstances and so forth? I mean, we could make that list. We could work our way through it. But I think the larger point is that we need to be careful what we're assuming there. I think we're assuming a lot about the need for resources, the motivations that any instrumental value convergence would imply there. Maybe that all follows, and maybe it doesn't. Of course,
there are assumptions both ways, but I'm simply saying that what has held at every order of magnitude up until now, from self-replicating molecules to elephants, simply holds for the orders of magnitude that follow, that there's nothing special about our present arrangement. there's no new ingredient I'm throwing in. I'm simply saying that nothing new happens when you get to galactic scales. You're the one who seems to have a belief in a very sharp discontinuity at exactly the transition to AGI, where suddenly it's not governed by evolution anymore. And I understand that intuition because we don't behave entirely as though, in many important ways, we don't act exactly as we might act if pure reproduction of genetic material, or even any information material, memes, whatever you like. I mean, we're not oriented directly at reproducing any unit maximally. That isn't a good explanation of our behavior. And you have an intuition or a belief, and there's reasonable evidence for that maybe that's a factor of increased intelligence, and we've decoupled ourselves from those ancestral drives to a significant degree, and that's a product correlated with increased intelligence, and therefore if you have an AGI of even greater intelligence, then it would be independent of those forces to an even greater degree. And I think that isn't a weak argument. However, the counter argument I would make is that it's not, I would say it seems to me that it's actually more like a consequence of our intelligence. We freed ourselves from resource constraints to some degree, and therefore we had the slack in order to not be governed very directly by those incentives. But if that slack were to be removed, because maybe we're just not cognizant of the fact that we do need to compete on a higher level. I mean, suppose we were to get a message tomorrow from, whatever they're called, the Solarans, Tri-Solarans, right, in the three-body problem. We get a message tomorrow from some other species that says, okay, good luck, we're on our way. Then, well, maybe our relaxedness and our willingness to cooperate across borders and all sorts of other things we like about our current civilization would maybe look a little like one luxury too far, and all our descendants for 1 million generations are on the line. So, okay, party time's over. Now let's get serious. That could be the case, right?
Yeah, it certainly could. So let me point to a couple of other assumptions that we could challenge here. So one that I pointed to is the assumption that additional resources continue to have value, that there's a continued return on investment to expansion. That's one assumption we could challenge. Another one is the assumption that competition is open-ended and there's no limit to escalation, right? But if you look at human technology for warfare, we have a very abrupt discontinuity, which was the development of nuclear weapons. And that really did change conflict in a fundamental way, because nuclear weapons are at least at the largest of them, and large arsenals of them, not tactical nukes, I guess, but the very, very large ones. Those are just a trump card. It ends warfare because you so rapidly acquire such an overwhelmingly destructive defensive capability that it just takes conflict off the table in some sense. And one could imagine upper limits to technology being achieved relatively quickly by something like a super intelligence. We don't know. That's an open question. And so there's an assumption there. Well, your technology will continue to improve. Well, for how long? Where's the limit? Where is the actual fundamental physical limit in our universe for how powerful our technology can become? How much control we can have over, matter, energy, information, time, space, etc. And it could be, we don't know, but it could be that you very rapidly reach absolute limits of that capability. For example, once you invent artificial intelligence, it could be that you very rapidly approach a ceiling. And it could be, for example, that at that ceiling, defensive capability vastly, overwhelmingly exceeds any conquest capability, so that it's trivial for any entity to defend whatever territory it's got. Now, that doesn't preclude the idea that you might still want to expand and acquire territory, but it could be that the grabby alien hypothesis could mostly hold true, and there could be a lot of frontiers of expansion out there. But when they meet each other, there's no conflict. They just stop expanding, because conflict would be well, it'd be madness, in the same way that going to war between two nuclear powers is madness. And we could see something similar to that. That could be a condition. Now, again, this is just it's one possibility. What is its likelihood? We don't know. But we have to be careful what we are assuming, if we're assuming that that's not a possibility. And the assumption that you have open-ended expansion and open-ended escalation because you have the potential to have greater and greater technological power. These things, if there are limits, they imply different dynamics than if they're open-ended and there's a chase or a race condition going on, where the finish line is way out ahead, millions or billions of years into our future, for example, before we reach the limits of technology. That's a very different looking universe than one in which, we're as advanced as we can get by the year 2250. And then we could be, for example, completely confident that nothing could assail us. No force in the universe could threaten us if we have reached the limits of technology in our universe, and the defensive capability is such that the offensive capability is something you can just dismiss.
Yeah, but
that is not an impossible circumstance at all.
Well, but I think
our universe would look very different than one, characterized by evolution, by a simple extension of the evolutionary paradigm we've seen up until now, right?
Well, but I think it's basically a perpetual motion machine that you're asking for. So the second law of thermodynamics basically says fundamentally offense is easier than defense, right? I mean, I can chuck a black hole into your solar system and I don't really have to care about the details. You're wrecked. You're not going to do anything about that. To defend against the black hole, I don't know what you're going to do, but that's going to be pretty complicated. It's always going to be, at least within the realm of physics that we can foresee, it's much easier to destroy things than build them, much easier to attack than defend. Like our current circumstance with, the difficulties of attack in human history are mostly to do with logistics and, the risk involved in committing so many resources and things like that. Well,
defense is still about destruction, though.
Yeah, but you have to.
You have to have a perimeter that you're defending, but at that perimeter, your destructive force could be overwhelming, right? You guys are closer to being physicists and obviously than I am, so you have to tell me. I don't know if there's a way to defend against a civilization that can hurl a 100 solar mass black hole right at you. Maybe there isn't a way to defend against that. I don't know. Maybe there isn't. But maybe you can surround your territory by a dozen of those things, and then everybody else in the universe knows they're at that level where you just do not fuck with them.
Yeah, that's right. That's was it launch on warning? It's like there's a black hole coming. I'll launch one at you. Yeah, okay, fair enough. But those things might all be true, but it's not. I think what I want to say is that it doesn't seem to me like I don't see any slam dunk argument that my point of view is extremely unlikely. I'm not going to say that I'm sure you're wrong, but it seems there's a very hard to rule out with high certainty the kind of picture I'm painting of what the landscape of competition looks like in the galaxy.
Yeah, I agree. It's difficult to rule out. I guess my argument is that we have to be careful about what assumptions we're ruling in automatically.
Sure.
So competitive dynamics is one of those things that we have to be careful about ruling in automatically. That presumes that there's some benefit to remaining distinct. For example, like there's some benefit for two alien civilizations to remain distinct. For all we know, it will become just manifestly, automatically clear to artificial and superintelligence that assimilation, synergizing assimilation, that just unifying with any other similarly advanced civilization you can find is the obvious and desirable thing. That's just overwhelmingly, you cannot wait to encounter another civilization because you can be overwhelmingly confident that they can't wait to encounter you and just merge with you. And right now, the way that Darwinian selection works in biology is that, you know, organisms have boundaries and the reproductive units are separate and have borders, and so there's competition over finite resources to preferentially or differentially replicate the replicating units, and those units differ from one another within bounded competing systems, what we would call organisms. But we've already seen in the case of and it was a great leap, and perhaps one of the elements of the Fermi paradox that's most powerful is the leap from unicellular to multicellular organisms. And when that occurred, the cooperation between organisms totally overwhelmed the logic of competition between individual cells, and multicellular organisms became very successful. Now, there are still single-celled organisms, and they're super duper successful. But multicellularity there's already an existence proof for the value of that. And it could be just totally obvious to extremely advanced civilizations that have the capacity to think about these things, that, yeah, what do you want to do? You want to become multicellular with any other advanced civ you can encounter. That's fantastic. That's much, much better than competing with or eating one another, whatever. Again, now I'm not saying that's likely. I'm saying assuming that, just not recognizing that and assuming that that's not a possibility by assuming competition is not necessarily an automatically well-grounded assumption. You have to challenge that.
Well, but on those terms, yeah, we meet at the border of our expanding spheres of influence, and we compare tech trees, and then if my tech tree subsumes yours, then, bye-bye.
Yeah, that's for sure. It's certainly a possibility. But I mean, again, if the hard limits of technology are easily reachable, like within a few centuries, for example, for human beings, then any civilization encounter will be between equals. Just almost certain to statistical certainty, very close to it, because the chances of encountering a civilization that's close to you but not quite at your level is just vanishingly small. Like encountering them in the right 10-year window, for example, is probably just vanishingly small. And then if you encounter any civilization that's less threatening than that, well, then they're not a threat to you at all, and subsuming them is trivial. I actually think I don't know what to expect as far as ceiling on what the limits are for technological power, the limits of tech. But I suspect that we'll probably slam into them pretty quickly. That's my intuition at this point. I don't think we've got, sort of millions of years of progression in fits and starts or whatever ahead of us. I think we probably hit the ceiling pretty quick, a few hundred years maybe. And then that's it. And then any other civ is going to be at that same level.
Yeah, I could see black hole engineering getting pretty wild if some of the math around ADS, CFT, and some of this holography stuff is true. There could be very exotic things we can do, engineering kind of bulk states near black holes or something. So. Yeah.
Well, so here's a question for you guys, because this is maybe something you guys can speak to with your expertise. I'm really interested to know. But one of the most provocative possibilities I've heard of for the Fermi paradox is that civilizations just disappear into black holes. That just that there's some value to just basically manufacturing or otherwise. Just diving right into one and doing engineering and existing behind that event horizon. And I don't know what all the reasons are. I think there are multiple reasons. One of the reasons is defense. I mean, if there's an event horizon there, you head in there, well, then you don't have to worry about anybody chasing you in there if there's no coming back. So maybe that is a very, very powerful defense mechanism. is just set your entire civilization up behind the event horizon of a big black hole. I've also heard that it's a way to fast forward to the end of the universe, whatever that is, and maybe it will become obviously desirable to do that. I don't know if that's the case or not. So yeah, what do you guys have thoughts on the whole? That's where all the advanced civilizations are, is inside black holes hypothesis.
Yeah, I don't know about getting inside a black hole. So what some modern physics suggests is that there's dualities between quantum field theories in different dimensions, so that something that looks three-dimensional when you probe it in a certain way, as we do with our senses and the way we interact with the degrees of freedom out there in the universe, appears three-dimensional, let's say, in space. But from another point of view, and this sort of has to do with black holes being present, from another point of view, it looks two-dimensional. And there's a sort of correspondence called ADS-CFT between gravitational theories in dimension n+1 and what are called conformal theories in dimension n, so in this case 3 and 2. And that sort of relates more computational views on things, so there's sort of an idea that quantum algorithms running in the two-dimensional thing sort of correspond with physical processes involving gravity in 3 dimensions. So I can easily imagine that with sufficiently advanced technology, you just see the universe in a very different way. So that, I mean, ultimately, if you're an information-based life form, like you're an AGI, and all you really care about are computational degrees of freedom and computing and the rocks and the trees, and even the number of dimensions isn't that important to you. It's just, I mean, you can simulate it all anyway. So there would be a strong evolutionary pressure for an intelligence-based life form to basically translate itself into whatever degrees of freedom are the most computationally favorable. Maybe that means using less energy so you last longer, or maybe that means, in the context of competition, being distributed in some way that's very hard to attack unless you've similarly made that transition. So from our point of view, in the bulk, in 3 dimensions, maybe what would it look like for that intelligence to be out there? It would be embedded in some very strange way into entanglement around black holes in a way that we just wouldn't be able to perceive. It would be distributed spatially, so it wouldn't actually be localized in a way we could interact with our sticks. So that's not disappearing into the black hole, but it would be encoding your civilization into entanglement, basically like a quantum error correcting code in some very stable way, but which can't be interacted with locally. So there could be a whole civilization encoded in the boundary of a black hole or something, which is just inaccessible unless you have that technology yourself. So there's those kinds of things. I mean, we can see dimly the possibility of that with our meat bag brains. I don't think it's exotic to imagine that advanced intelligence can do pretty complicated things with the underlying structure of quantum gravity somewhere or other. Once you get, and who knows what's beyond that? I mean, we don't know what the fundamental theories of physics look like, right? So I think there could be many, many layers of fairly exotic stuff, which just, you don't exactly leave the universe or go inside a black hole, but you've encoded your civilization into degrees of freedom that we're not usually interacting with, right? Like, you could, in principle, build a machine out of gravitational waves, run your computer that way, spend it across a galaxy. It's not impossible, right? In the same way you can run a computer with optical waves.
I mean, one of the more exotic proposals for resolving the Fermi paradox, well, maybe it's not more specifically, I guess it's an exotic case, but it's one case in a general category of solutions. The Fermi paradox is the idea that dark matter and dark energy are that those that's the evidence of where all the aliens are, and we don't know how to interpret it because it's not legible to us. But if it turns out it's completely self-evident at some point that those are the substrates you want to utilize for what information processing or whatever advanced civs decide to do with themselves. Maybe everywhere we look, we're just seeing the evidence of advanced technology, and we just don't recognize that that's what it is. And that's the idea that dark matter and dark energy or whatever, these remaining mysteries in physics that are quite stubborn. Maybe that's a little bit silly, but the larger principle is that there could be, or the argument that there could be evidence already which we don't recognize for the activities of advanced civilizations, and I suppose that's a possibility. Another thing that I wanted to ask you guys about is it's sort of from a thermodynamic perspective and an information theoretic perspective. It seems like because you mentioned this idea, there seems like to me, very naively looking at this with a total layman's understanding, it seems like you've got sort of two contradictory features. Not contradictory, but well, I don't know. I'll just say what they are. The first you mentioned already, Dan, that it's easier to destroy than create because of the sort of the arrow of time and just entropy tending to increase in the direction. In that direction of the arrow of time. And then this other interesting fact, to my understanding, again, maybe this is wrong, but my understanding is that, again, like with black holes, quite a famous bet that Stephen Hawking made, that you can't destroy information, that information is not destructible in a sense. It's interesting to ponder what that might mean for an advanced civilization's vulnerability. So, for example, if you can't destroy information, are there invulnerable ways technologically that one could imagine to basically to just instantiate yourself? In other words, if information is not destructible in some fundamental sense, it's clearly destructible in relation to human beings right now. I mean, when a human dies, and that, the information we care about is certainly destroyed from our perspective, but maybe in a sense it's not. But with advanced enough technology, could you realize proper invulnerability? That's my question. Does that make sense in the context of an increasingly disordered universe, but a universe in which information is preserved, or conserved, I guess is the right word.
Yeah, you have to be careful with that. The notion of information you're talking about there. I mean, technically, what Hawking is referring to is the fact that the time evolution in quantum mechanics is unitary, which means that it's reversible. So, from the point of view of the wave function of the universe, so quantum mechanics would say, if you run it forward in time, all the information is still there, precisely because that mapping is invertible. So you could run it back the other way in principle and get back the information that was there. Now, that doesn't mean that naturally the time evolution of the universe will do that and redeliver the information to you, but it's in some sense still there. It could be that the information has now been distributed to the four corners of the observable universe, and you'd have to bring those exact 4 electrons back together in order to reconstruct the state that was there before. So it isn't a prescription for how you would do it, and it doesn't reflect the energy cost that it would take to actually implement that reversibility. Yeah, I mean, you have to. It's a complicated topic because it gets into the gap between kind of classical physics or macroscopic physics and quantum mechanics. So I think, well, if we're talking about very advanced civilization, who knows? But in practice, the obstacle is something like computational complexity. So you might be able to reconstruct the previous state, but it would become prohibitively expensive in computational complexity terms. And there's probably like hidden laws that we don't quite know how to frame yet, which say that actually it's unrecoverable, but the unrecoverability is like in some, I don't want to say practical, but So I think I don't really see much prospect of there being true invincibility in that sense. Yeah, it's
the other sense that I'm kind of curious about, and this goes back to sort of dark matter. My understanding is that there are a number of different proposals for what the explanation for the dark matter anomaly, the seeming, missing mass or whatever, however it's framed. A number of different explanations. No one is a leading candidate necessarily at this point. But one of them is that I'm, to my, again, very poor understanding, is some sort of particle that's just very weakly interacting, minimally interacting. Like it's very, very difficult to interact with that.
That's the
with this particle
theory.
Is that sort of that's probably an older proposal for the explanation. But so again, I mean, I don't know if this is prohibited necessarily in physics, but for example, it might be an attractive option for a civilization to instantiate itself in a form with which, or in a form that would be very, very difficult for anything else to interact with. Now, I don't know if that's possible, but if it were possible, for example, then that might be an attractive option for an advanced civilization, would it not?
Yeah, but I mean, you could say that about our civilization as well, and yet it's useful to also have the tractors out there rearranging things because the physically legible options are also useful, and you need to do both, right? You need the spies and you need the secret black program, but you also just need to build the military bases and the runways and rearrange physical matter. I don't know that it's like, how can you be sure that you can go off and hide in the dark matter and that so you left completely open the territory of normal legible matter, and you're so sure that if somebody takes over all the ordinary matter in the galaxy, there's no way they can leverage that to reach you. Of course, you have more options when you control more low entropy states, which is what it means to conquer the galaxy. So I feel like you should, I mean, if I was running the grabby alien civ, I would take over the galaxy just to be safe. Why not? Right? There's no reason not to, unless you've got a mathematical proof that it doesn't help you.
Yeah, that's interesting. Another possibility. Sorry, I was going to say one more possibility for. I mean, again, we were talking about the Fermi paradox. Where are all the aliens? Gravity, the grabby aliens. Solution is one possible solution. One other that we haven't talked about is that it could become self-evident to any, and this is lots of sci-fi's looked at this, could become self-evident to any sufficiently advanced intelligence that our universe is just crap, and that it's better to just go somewhere else. And if other universes, or some other domain is accessible, multiversal, or however you might want to think about it, that it could be that anytime you reach a certain level of sophistication, you just disappear, you just leave. Because maybe our universe is really suboptimal for whatever it is that intelligence likes to do. Maybe information processing is part of that, or whatever. Who knows? We don't know what very intelligent things are going to like to do or want to do. But one possible explanation is that whatever they want to do isn't as easy to do here as it is to do fundamentally somewhere else. In other words, not in the universe that we perceive anyway. Now that is that's another question. Are there other universes in this sort of larger, super duper macro verse, multiverse kind of thing? Are there other universes with different physical laws that are much more amenable to computation or whatever else, if different fundamental constants, or I don't know all kinds of possibilities there? And is that how likely is that as an explanation for the Fermi paradox?
Yeah, I mean,
there's one more that's related to that, which is the simulation hypothesis, but that's okay, set that aside.
Well, I mean, the combination of those two things is essentially what I was saying before, right? So, I mean, to embed your digital civilization into other degrees of freedom, whether those are entangled states or something else we can't describe mathematically right now, is essentially to escape what we mean by the universe, which is, I mean, when we say the universe, we mean the degrees of freedom we interact with, right? Like we interact with the electromagnetic spectrum, we interact with the strong and the weak force. We're interacting not in a very sort of, we don't interact with gravitational degrees of freedom like in an information exchange way, usually, right? We're not embedding programs into, modes, gravitational waves that bounce around inside our solar system or something, even though that's totally plausible that you could embed information into that. We don't do that. So there's many, many degrees of freedom that make up the entropy of the universe that we just don't know how to embed information into. And to say there's like a whole other spectrum in which we could compute is not exotic. And to enter that spectrum and embed our civilization into it would be to basically leave the physical universe in the sense that we mean it in 2023. So yeah, that's kind of what I was saying. Let's come back though to the original topic of little green men and crashed ships and shit like that. So given what we've just discussed, that I think gives some context to the reason why, and I think I'm on the same page with you, Adam, that given all that, and that it seems like once you get something like AGI, you get pretty rapid progress, at least relative to our history. That's why it seems so implausible that you'll see like drones or ships. I think the thing that, I mean, I was kind of watching with interest until I heard, is it David Grush? I don't know how to pronounce his name. This recent whistleblower, I guess you could call him. He said something that I was kind of following along. Like, oh, this is pretty cool. Until he said something about, yeah, and they have bodies, and then I'm like, no, don't say that. That ruins the whole thing. Like as soon as they say that there are alien
as soon
bodies,
as they said vehicles, it did it to me. I didn't even need to get to bodies. It crashed. I mean, crashed vehicles is also silly, right? I mean, the crashed implies a whole lot of things. A vehicle beyond just vehicle, right? I mean, like that. It implies that the vehicle's dumb, that it's not saturated with intelligence, right? It's not a computational substrate. It implies that there's no, sort of dynamic. Nothing dynamic about the material it's made out of. In other words, it's not self-organizing or self-rearranging or self-destroying, self-destructing. I mean, we can already imagine building macroscopic materials and objects with that are highly programmable and dynamic and so forth, right? They can rearrange themselves and so forth.
Yeah.
So the idea that you have dumb matter and a machine made out of dumb matter, and that machine is so kludgy and clumsy that it can crash. This is all just preposterous. And then to add to that preposterousness, it's got occupants, there's passengers, and there's some other vehicle riding inside that vehicle, because that's all a body is a vehicle for intelligence and effectuation, like influence of the environment around in the surrounds. This is all just silly. It's just ridiculous. It isn't how you would do it if you could do it better. We can imagine all kinds of ways in which you could do it better. So yeah, I didn't have to get that far. As soon as I heard vehicles,
well, maybe the aliens aren't godless transhumanists like you, and they actually want to go themselves. I
think Douglas Adams was probably closer to the truth, which is that, I mean, I think it's far more plausible that aliens are just having a laugh, and why wouldn't you just tease and poke and have fun and joke and amuse yourself with this stuff? I mean, I think that's more plausible. Certainly more plausible that an advanced if an advanced civ was crashing stuff on our planet, vastly more plausible that it's a joke or an experiment or something like that than it's a genuine, a legitimate of negligence or failure.
Okay.
In other words, I think it's overwhelmingly likely that it would be deliberate as opposed to accidental. Even if we were to even if we were to accept that that's what it is, these are extraterrestrial vehicles. I would still just be flabbergasted if they weren't crashed on purpose.
Well, let's get serious for a minute. So I think we both agree that the information that's been released, say by the defense organizations in the US over the last few years, I mean, you can dismiss maybe a lot of these events, but it does seem like there is some phenomena there. Now, we don't know what it is, but given, I think you've probably been following it a bit more closely than me, but I've read quite a bit about it over the last few years. Given all that's going on, let's give our the modal explanation. What is the most likely explanation for all of this? So I'll give mine, and I'll see if you agree. So I think the simplest explanation for what's going on and these craft that seem to be being observed regularly by military pilots and so on with exotic performance characteristics. The simplest explanation, I think, is that there are scattered around the Earth, buried or not, detritus from other civilizations. Perhaps Oumuamua was one of them. They have exotic materials in them. They're not exactly easy for us to understand, but some of them have been discovered over the last 100 years. They're being studied in various places in, secret military programs or whatever, and some of that has filtered through to capabilities. So maybe you guys or somebody else has some simple drones that have kind of exotic capabilities, and that's what's buzzing these pilots and so on. I think it seems highly implausible to me that they would be visible and noticeable if they were actually if they were actual alien objects. There's no reason for them to do that unless they're prepping us for first contact or something. I don't know. So it seems to me like probably they're terrestrial, but it may be that I don't find it incredible at all that there's quite a lot of junk floating around out there, and some of it lands on Earth from time to time, deliberately or not. So that seems to me like the most plausible explanation, unless it's all a hoax. But I'm starting to feel like it probably isn't all a hoax. I don't know if you have an opinion about that.
Well, my opinion is pretty strong that there's no extraterrestrial anything, for the reasons that I've mentioned earlier. I don't think there's a bunch of detritus floating around. I think that implies too many things about other civilizations that are implausible. Mainly that truly advanced civilizations produce artifacts that aren't intelligent. I think that's very unlikely. I think it's overwhelmingly likely that any artifact from an advanced civilization is well. I think it's likely that any artifact is totally saturated with intelligence and is in effect alive in some sense. The presumption that there would be dead detritus around, I think it sort of fails on its face. Smart matter seems very likely to me. Nanotech machines seem very, very likely to me. Machines that simply don't fail. They might go into a low power or a shutdown mode or something like that. But the idea that nanotech fails doesn't really work for me. So I find the idea that there's detritus that's discoverable and that we've discovered it. I find that just implausible in itself. Adding to that, I find it completely implausible that secrecy have been maintained for many decades on this, especially international secrecy. I find that utterly, totally implausible. It's really well documented that it's almost impossible to keep any secret beyond a few dozen people. And even the greatest secrets that humans have ever tried to keep, including things in the Manhattan Project, for example, leaked out. And very quickly, not decades later, but really quite quickly. And so the idea that there's an international conspiracy and there are, multiple nations coordinating on moving, remains of spacecraft around and so forth, and that none of this has ever escaped and not a shred of evidence has ever been found and no real photograph and nobody's ever stepped forward. This is completely implausible to me. I just don't have any faith or belief that human beings are capable of maintaining a secret like that, let alone, even if it was just the information, let alone organizing programs around them and dedicating substantial amounts of resources to those programs and keeping those programs in secrecy, not just the facts, but the programs. Totally implausible to me. What seems much more likely, almost certainly in my mind, the explanation is that this is very much terrestrial technology. It's human technology. The explanations are mundane. Pilots moving at high velocity don't know what they're looking at or seeing. Instrumentation is problematic. Visual inspection is deeply problematic. All kinds of visual oddities and phenomena that even when your eyes are working perfectly and your brain is working perfectly, things can look very strange from a long way away that are moving fast, and if you're moving fast. And so, the most compelling evidence that we've seen, for example, that had been published, some of it is very clearly like, kites and balloons floating around or bits of them floating around, made to look like they're moving fast because of parallaxing and stuff like that. Now, the ones that are sort of truly baffling, where you have, you've got an F-18 pilot and his co-pilot, and they've seen something that is moving in a way that really looks physically impossible. I think there are plausible explanations for that too, that are decidedly terrestrial. So, for example, these orbs, or things that are circular or ovular shaped, ovoid shaped, that move very quickly. I think that could easily be spoofing technology for radar, and you could have a combination of energy and particle beams that create exotic effects that manifest in visible spectrum and on radar as solid. So, for example, say you have multiple intersecting beams of energy. Where they intersect, you could get a sphere of plasma, for example, high temperature plasma. And because you can steer those beams around in the same way that you can steer lasers around at a rock concert, you can make an object look like it's moving in impossible ways. But it's not an object. It's just the intersection of a bunch of laser beams. And where they intersect, maybe they're ionizing the noble gases in the air or something. And then you get what looks like a white or a shiny sphere moving like a laser pointer, in the same way that you can trick a cat into thinking that an object is moving in impossible ways and chasing it around your room. I think this is a vastly more plausible explanation for sort of the impossible acceleration of spherical objects.
But what's the source of these high-powered laser beams?
Well, all of these sightings occur in military test areas. They never occur in downtown Manhattan. They never occur in front of people with cell phones. They never occur anywhere where there's anybody to witness them, except out on the gunnery ranges off the coast of California, over the naval test zones, and out over the Atlantic, over the Air Force's test zones, and in Nevada with the Army and Air Force test zones. All of the sightings of those sorts of things are very peculiarly located where only military personnel can observe them. And this in itself is preposterous, right? So where is all the high resolution footage if there are more than 8 billion imaging devices now? Where is this stuff? Where's the evidence? There's none. There's nothing. The stuff that's coming in is being observed in exactly the places you would expect experimental military technology to be observed. Exactly where. And then, of course, the other element of the explanation is, well, what's the government's position on all of this? Well, what would your position be if this was experimental tech? UFOs are a great cover. It's a perfect psyop. It's a great smokescreen. It throws the public off. It's a distraction. It creates mystique for your adversaries. Oh, does China really think the U.S. might have UFOs? We'll never catch up to them if they're reverse engineering spaceships. Wow, that's why they're 20 years ahead with their stealth airplanes. It's preposterous. All of it is preposterous. All of it is utterly preposterous. There's nothing. There's nothing out there. There's no aliens. If there were, they're here. There's octillions or however quintillions of nanobot dust probes everywhere. they're already in us and around us and inside us, observing us that way. Aliens may well be here. We don't have any idea. We would never know it. They would, if they didn't want to be observed, they wouldn't be observed. They'd never crash a vehicle ever. That's ridiculous. And it's anything that we're looking at is definitely either atmospheric phenomena or mundane shit up in the air, like party balloons, Mylar party balloons, which come in all kinds of shapes and sizes, including the ones that are deliberately shaped like UFOs. Thank you very much. And quite big ones, 8 or 10 feet across. You can get them at the party store in my town, for example, like the one they shot down with a $20 million missile over Lake Huron a few months ago, preposterously. They shot down an octagonal party balloon, 6 feet across, that you can buy at the party zone in Ann Arbor and inflate with helium right there. That's what they shot down with a Sidewinder missile. With 2 Sidewinder missiles. They missed with the first one. It's ridiculous. Yeah, so anyway, I'm sorry I'm starting to go off the deep end and rant a little bit here. But no, I think it's all very mundane and preposterous. And I would be dearly loved, of course, if it were the other way around and if all of this was actually aliens. But it's not.
Well, we have the quote of the day. Adam says, "Aliens are inside you." That's all we need to know.
No, if they were here, if ASI, say one of our super intelligences discovered a 19th century equivalent technology civilization in another star system, and went there and wanted to observe them, how would our ASI in the year 2150 do that? It would do that with trillions and trillions of nanobots, and it would just dust the entire world in those sensors, and they would be everywhere. They would be on every surface. They'd be everywhere, seeing everything all at once, mapping everything, sensing everything, observing everything, looking, listening, everything. And if you've got microscopic machines, sensors like that, hell, they could even be biological. Just program your bacteria, put a little bit of a sneaky Wi-Fi or remote, kind of thing inside what's otherwise a fairly, mundane looking bacteria, and have that roam around inside the organ. Why not observe the inside of the organisms that you're interested in? Mm-hmm. I mean, this is if this is what a super intelligence would be able to do, why would you send a Chevy Nova or a Toyota Corolla with a couple of cameras on it with no brain inside it that might crash? It's preposterous. That's not how you're observing another world. It's ridiculous. If you're an ASI, and that's just our tech 100 years from now, 150 years from now. Yeah. So if you're a million years more advanced than us, well, anyway, so sorry, I started out quite serious, that was great. And I don't even have any beer in me right now. Boy, if I had a couple of beers, it'd be even worse. You got me riled up.
Yeah, that's great. Oh, well, that's less exciting, I have to say. It's disappointing.
And I should say, I mean, seriously, as a obviously a lifelong science fiction nerd and an optimist and a tech and transhumanist sort of enthusiast, all of that stuff, I would be absolutely the first person to be excited and celebrate contact with an alien civilization. I mean, seriously, I just cannot imagine anything more thrilling or more important in the history of our world than confirmation that we are not alone in the universe and that there's other intelligence out there. This would be the most monumental, profound, and beautiful event that I can imagine. It's difficult to overstate any of that. So, I mean, I would be absolutely thrilled if this were true. But after having thought about it very deeply, after having thought about it a lot for a long time, I just don't see how the alleged evidence that we have makes any sense technologically at all. It just doesn't. I wish it did, but it doesn't make any sense to me. It's just silly. It's exactly what we would cook up as a story, right? In the same way that what would you imagine the ancient Greeks what would you imagine their musings or myths about advanced technology to be. It would be winged horses, and it would be all the things exactly that you would imagine they would come up with. Well, that's exactly what we're doing right now. What do we see? Exactly what you would expect us to see if we were making it all up. Unfortunately.